Well, now that we're playing around with obtuse angles, angles that are greater than 90, there's something we need to be aware of, something I call Biff's two-answer theorem. And the shortest way to say it is that sometimes when you hit a shift sine, shift cosine, or shift tangent, the calculator's not going to give you the right answer. It's going to give you the wrong answer. So how can this be? Well, I want to kind of build up to this a little bit slowly. So the first thing, and this is almost a non sequitur, but the first thing is, remember we defined sine walking all the way around a circle, rotating around a circle. We defined cosine, tangent. We defined all our trig functions rotating around a circle. Well, this all students take calculus thing is a quick way of knowing what quadrant you're in if you know that the sine is positive, or maybe you know that the cosine is positive, or maybe you know that the tangent is positive. If you know the sine is positive, you know you're in one of two quadrants. If you know the cosine is positive, you're in one of two quadrants. If you know the tangent is positive, you're in one of two quadrants. Which quadrants? Well, that's what this all students take calculus thing means, or does for us. All, and by the way, this four-word phrase, all students take calculus, you kind of say that to yourself as you rotate through. All students take calculus. In other words, all students take calculus, like this. And the A is for all, because all, and it says it right here, all trig functions are positive in the first quadrant. The S is for sine, because the sine is also positive in the second quadrant. The T is for tangent, because the tangent is also positive in the third quadrant. And the C is for cosine. The cosine is also positive in the fourth quadrant. Okay, so down here, example 1. List the two quadrants where sine is positive. Well, it's going to be positive in the all or the sine, right? In other words, in quadrants 1 and 2. Sine is positive in quadrants 1 and 2. B, cosine is positive. Well, all students take calculus. So you need the all in the calculus, which means you need either quadrant 1 or 4. So I'm just going through the ASTC, all students take calculus. And when I'm doing tangent, I'm going to stop when I get to the T, right? So all students take calculus. So that would be the first, skip the second, and the third. So sine is positive in the first and second quadrants. Cosine is positive in the first and fourth quadrants. Tangent is positive in the first and third quadrants. It's just the way it works out. Now if I ask the other questions over here, sine is negative. Let's switch colors maybe. Sine is negative. Well, it must be negative in the other two quadrants. So if it's positive in 1 and 2, it must be negative in 3 and 4. That makes sense, right? And if this is positive, the cosine is positive in 1 and 4, it must be negative in 2 and 3. And if the tangent is positive in 1 and 3, it must be negative in 2 and 4. So you can very quickly, without having to think about any angles or sides that are positive, negative, anything like that, it just gives you a very fast, very efficient way of knowing what quadrant you're in. If you're given a clue, sine is positive, then boom, you know you're in the first or second quadrant. If you're given a different clue, cosine is negative, then boom, you know you're in the second or third quadrant. This is going to come in handy today. Okay, so Biff's two-answer theorem. We're almost ready to state it, but first let me go to the second page and do some of these. What two angles, and this is the situation that we're going to face a lot. What two angles between 0 and 360 have a sine of 2/3? Well, sine is positive in the first quadrant, all students, and also in the second quadrant, right? So I'm going to have to draw two angles, one in the first quadrant, one in the second quadrant. Now I always draw the first quadrant first. So a sine of 2/3, remember sine is opposite over hypotenuse, or when you're dealing with these xy axis stuff, it might be easier to think in terms of y over r. So you want to draw a little triangle over here so that the y over r is 2 to 3, something like that. And this will be the angle theta. And I might as well ask my calculator what that is. So of course I hit the shift sign of 2/3. And my calculator says shift, sine, 2 divided by 3, close parentheses, equals. It says like, 41.8 degrees. 41.8, in fact, I'm going to make that a different color. I want to emphasize this. 41.8 degrees. That is, well, I can't say the answer. That is one of the answers, right? Where's the other one? Well, you'd want to draw a triangle in the second quadrant that was basically had the same y over r, right? So it would have to look kind of like a symmetrical, like a reflection over here. It looks like I've reflected across the y-axis here, right? So I've got a y over r, this is the y, this is the r, of 2/3. And so this angle, now this angle would technically be from here to here, right? Now you can tell by symmetry that this is the same 41.8 that we got over here, 41.8, right? That's the same. But the angle that we're talking about here is up here, theta equals. And so what is that angle? Well, it would be 180 minus 41.8. So let me put that in red. 180 minus 41.8. So I kind of filled up my diagram real fast. But one answer is 41.8. And the other answer is 180 minus 41.8, which is 180 minus the answer circle 138.2. Two-answer theorem. Get it? There's two answers. You hit shift sign of 2/3 right here, and you got an answer. You got that one. But was it the right answer? Kind of depends what triangle you're looking at. If you were looking at this triangle in the first quadrant, yeah. But if you're looking at the triangle in the second quadrant, no. You'd have to actually do 180 minus the theta. Okay? So this is, maybe I'll even write this down. This is the theta from the calculator. And then this is 180 minus theta from the calculator. Okay, so that's how it works with sine. You might want to try this next one yourself, just to see if you're catching on here. What two angles between 0 and 360 have a sine of, and they give you a negative 0.6? Pause. Come back. Okay, so this time the sine is negative. Not in all students take half, not in the first and the second, but in the third and the fourth. The third and the fourth quadrants. So what I can do is I can start drawing one of these, and I'm going to go to the third and the fourth quadrants. So remember, sine is still y over r, opposite over hypotenuse, y over r. So if y over r is negative 0.6, I must have something like, I don't know, something like this. The y would be negative 0.6 and the r would be 1, right? Because that makes a ratio of 0.6 to 1, or negative 0.6 to 1. So this angle, which is a negative angle, and I'm thinking the calculator is going to give us that answer. So let me do that real quick. Shift, sine of, where is it? Negative 0.6, boom. And my calculator says, and I put this in red, theta calculator is 36.9, or negative 36.9 degrees. And then the other answer is going to be, well, it was this. It's going to be the same, 180 minus theta calc, which is, should I do it that way? Yeah, I guess I should. 180 minus the answer, and notice that it's actually giving us 216.9 degrees, which would be, let's go to a different color, which would be the angle you get. Here's my negative 0.6 over 1. It would be this answer here, right? Little over 180, 216.9 degrees. So it works really, really well. So I was able to do the old 180 minus trick again. Now if I had done it, if I was working it out over here, I might have said something to the effect of, well, I know that this angle is 36.9, which means this angle is 36.9, and so I can say the real angle is 180 plus 36.9, and that's how you get to the 216.9. So you might want to highlight this part. So whenever you're dealing with the sine, it's always going to be this way. The calculator gives you one answer, the other answer is 180 minus theta calc. I've never really memorized this myself. One answer is what the calculator tells you. The other answer is 180 minus what the calculator tells you. So I've never really memorized myself because it's just I just keep falling back on these constructions, and it gets me in, you know, not very long. It gets me to the idea of 180 minus theta calc. Okay, so I did two sines. Looks like I got tangent next. Okay, fine, tangent. So first question, we have a positive tangent. In what two quadrants is the tangent positive? Well, it's positive. Let's see, all students take calculus. It's positive in the first and in the third quadrant, right? Because the t is here. So it's positive in the first and in the third quadrant. Okay, well, first thing I'm going to do, now remember, tangent is opposite over adjacent, or when you're playing around with this coordinate system stuff, it's y over x. So you want the y over x ratio to be 4 to 3. So something like this. I'm not saying this is the scale necessarily, but that would be one of our answers. I call that theta calc, theta calculator. Theta calculator is, so I'm just going to hit shift tangent of 4/3 right now, 4 divided by 3, boom, 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 and I'm getting 53.1 degrees. But there should also be an answer, it says, in the third quadrant. So that would be down here. Now if I want to have the same ratio of y to x, it turns out this is like a perfect straight line from here to here. Okay, so it's like a 180 degree rotation, I guess you would say. 180 degree rotation. So in other words, the calculator's giving you this. If you want to rotate 180, you would add 180. So that's a different thing than what we were doing for the sine, right? So for the sine, we did 180 minus theta calculator. Here we're basically doing 180 plus theta calculator, or theta calculator plus 180. And theta calculator plus 180 would be, what would that be? 233.1 degrees. Okay, so it's a different thing. We want to add 180 when you're doing the tangent. Add 180. Okay, you should try this one yourself. You might be a little surprised, but it won't be bad. Pause. Come back. Okay, so first of all, tangent is negative. Well, it was positive in the first and third, so it must be negative in the second and fourth. So I'm going to be drawing angles in the second and fourth. So remember, it's y over x is the tangent. So if I got a negative 0.237, that means something to the effect of the y is negative 0.237 and the x is 1, right? That makes a ratio of negative 0.237 to 1. And so the calculator will give us this answer. So let's ask the calculator, hey, what do you think it is? Theta calculator is, so I go a shift, I go a tangent, I go a negative 0.237, boom, and the calculator is telling me negative something like 13.3 degrees. Okay, so this would be a negative, it's negative because it's down, right? But that would be a 13.3 degrees. Well, where's the other angle? Well, once more, you would basically pull a 180, right? Oh, I'm trying to make this look like it's all one big straight line like this. So let me try to do that a little bit better. That's a little bit better. So you have to rotate or add 180 to it again, and that'll work. So theta calc plus 180 is negative 13.3 plus 180 is 166.7 degrees, which is the angle that you get. The 166.7, technically speaking, is the angle from the positive x-axis to here, right? So that would be the second angle. So yeah, I guess that was the same rule, right? So for sine, we had to go 180 minus the calculator, and for tangent, we go calculator plus 180. What do you do for cosine? Well, let's find out. So cosine, you got to do, guess what, something different. Which two angles have a cosine of 0.85? Well, it's a positive cosine. All students take calculus means we're positive in the first quadrant and in the fourth quadrant, actually. So let's draw something that has a cosine of 0.85. Now remember, cosine is adjacent over hypotenuse, or in coordinate axis land, whoops, it would be x over r, like this. So 0.85 would look something, and I'm not saying this is accurate, but something like this, a 0.85 to 1 ratio of x over r. What's the calculator tell us? The calculator tells us, if I go shift cosine of 0.85, the calculator, woo, Nelly. If I go shift cosine of 0.85, the calculator tells me 31.8 degrees. Okay, that's one answer. And the other answer is going to be in the fourth quadrant. So let's try to draw a triangle in the fourth quadrant that would have the same x over r. So what you actually do is you flip it down like this. So that's a reflection across the x-axis like this, up down. So if that's theta, I think you can tell just by looking at it, this would have to be negative theta, right? It's the same angle, it's just one's positive, one's negative. So also negative theta calc, or negative 31.8 degrees. And so these are the three kinds of motions that you got to do. You got to either 180 minus, 180 plus, or do a negative of the calculator, and it'll work. You want to try this next one? It's our last one of this set. What two angles, 0 to 360, have a cosine of negative 3/8? Ready? Pause, come back. Okay, cosine is negative, so it was positive in the first and the fourth, which means it's going to be negative in the second and the third. So I know I'm going to draw myself in the second and the third. I need a cosine, again, that's x over r, of negative 3/8, so maybe something like, I don't know, something like this. So the x is a negative 3, right? And then the r is a 1. No, 8, I'm sorry, 8. Negative 3 to 8 ratio that way, x over r. Okay, I can ask the calculator, hey, what's theta? And the calculator will tell me this answer, because remember, that's called standard position. So theta in standard position is, let's see now here, shift cosine of negative 3 divided by 8, close parens, equals, I get a positive 112.02 degrees. Beta calculator, 112 point, I'm just going to say 0.0 degrees. Cool. And where's the other one waiting for us? It's waiting for us in the third quadrant down here, right? That's what we figured out at first. And you just kind of do the old reflection over the x-axis this way. And that'll be a negative 3, that'll be an 8. And now this angle here, what is this angle? Well, I was saying that you could do this, negative theta calc, which would be negative 112.0 degrees. And you could. Oh, you know what? I'm falling for a trap here. Whoa, because it says angles between 0 and 360. Whoa, that's not between 0 and 360. So I'm going to say the other is, and I have to go, let's see now. Well, you could always add 360, right? You can always add 360 to get an equivalent angle. So negative 112, negative answer plus 360. Boom. So that would be 248.0 degrees. 248.0 degrees. Okay, so what is it that I'm really doing here? Is it 3? Yeah, I guess it's 360 minus. Yeah, that's what I would be doing. So let's go like this. Wait. Do 360 minus theta calculator, because that would be the same as adding 360 to this, right? So if I go 360 minus 31.8, I get 328.2. Which of course is the same as negative 31.8, right? They're called coterminal angles. They take you to the same ray or whatever. So that's what I really should be doing. So let's erase this. Ooh, nasty. Let's put this in here. 360 minus theta calc. Right. So down here I could have of course done the same thing. Or 360 minus theta calc. Boy, isn't it nice that you can take nice and neat notes. That would be good. So 360 minus theta calc would be 360 minus 112, boom, 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 which of course is 248 degrees. Okay, I think it's time we summarize this neatly way back on page 1, where it says Biff's two-answer theorem. Now let's try to state this kind of nicely. I'm going to say when you use shift sine, shift cosine, or shift tangent, the calculator always gives an answer, and that's supposed to say gives. Come on, gives. Always gives an answer between, and I think I want to say between negative 90 and positive 90 degrees. And let's just double check that here. So here the calculator said 41.8. Yep. Here the calculator said negative 36. That's between negative 90 and 90. Yep. Here it gave 53. Yep. Here it gave negative 13, again between negative 90 and 90. Here it gave 31. Here it gave, oh, I guess it didn't always, except for cosines. So I'll say usually. In fact, let's say this a completely different way. I'll just go like this. The calculator gives you one answer, but there's another one. And let's summarize our results. When you're using shift sine, there's theta for the calculator, and then there was 180 minus theta for the calculator. When we did a shift cosine, there was theta for the calculator. Let's see, shift cosine, that was the other one. You go 360 minus theta for the calculator. And when we did a shift tangent, it was theta that the calculator gave you plus theta that the calculator gave you, add 180 degrees. So this is like humongously important. Now, you're going to try to memorize that? Yeah, I suppose you could. Keep it handy somewhere, maybe. I think it's nice if you anchor your understanding on the spinning around and making the two triangles that both have the same sine, both have the same cosine, both have the same tangent. Now I'm just going to triple check that I'm doing this right. So for sine, 180 minus theta calculator, that's what I did, right? That's what I ended up with, 180 minus theta calculator. For cosine, 360 minus, that would be down here. 360 minus, right? That's what I did there. Yep, that's what I did there. And then for tangent, I don't have to verify it, I know this. For tangent, where'd I go? For tangent, you go theta calc or theta calc plus 180. So for the tangent, it always gives you an answer between negative 90 and 90, and that's why you're always going to add 180 to get the other one. I guess it doesn't work that way for sine cosine. But anyway, okay, good. Biff's two-answer theorem. Be aware of it, especially when we start playing with the law of sines next lesson, because you'll hit shift sine on your calculator and get an answer. Don't just trust it. It might not be the right answer. Look at the triangle. Maybe it's not that answer. Maybe you have to do a 180 minus theta calc to get the right answer. Okay, so this is important stuff. Important to be aware of, acutely aware of. So I wanted to end this. This seemed like a good place to squeeze this in. What about the angles that are right on the north, south, east, west, like 0, 90, 180, 270? Notice you can't really define a triangle. That, you know, how am I supposed to define a triangle? It doesn't come off the axis at all. But we can always fall back on sine is equal to y over r, cosine is equal to x over r, tangent is equal to y over x. And so if you rely on those definitions, you can answer these four questions. What angles have a sine of 0? Well, sine is y over r, so you need y equals 0. Y is 0 at this angle and at this angle, right? So that would be 0 degrees, 180 degrees. So both 0 and 180 degrees have a sine of 0. Cool. Next, what two angles have a cosine of 0? Well, that's an x over r, right? Cosine is x over r. And so you're looking at x equals 0. And x equals 0 here and here. So that would be 90 and 270 degrees. You can tell just by looking, where does x equal 0? Where does y equal 0? Okay. So let's get rid of those now. Hey, hey, ho, hey. Okay. Now we're ready. What? Have a tangent of 0. Okay, tangent. Remember, tangent is y over x. So actually, again, you need y equals 0. So it's the same as the sine. If the sine is 0, then so is the tangent. So 0 degrees, 180 degrees is where the tangent equals 0. And then an undefined or infinite tangent, that would mean a division by 0. That's how you get undefined or infinite. Your calculator might say error or something. I don't know what it says. It might just smoke. But anyway, if you have a division by 0, that's where you're going to get an infinite or undefined tangent. And if you want x equals 0, well, that brings us right back to here, same as the cosine, right? So same as, I should say same as cosine equals 0. So that would be the 90 degrees and the 270 degrees. So if you hit like tangent of 270, what does my calculator say? Now I'm curious. Tangent of 270, boom. It says math error. It's not really a math error. It's a division by 0 error. That's not a math error. A math error is when you get the sign wrong or something, you add wrong. Anyway, whatever. So cool. Now you're aware of how the trig functions work at the north, south, east, west points. Okay, so Biff's two-answer theorem. Again, just be acutely aware of this in the next lesson, especially, but really for your whole life. When you hit the shift sine, shift cosine, or shift tangent, the calculator might give you the wrong answer. Make sure you get the right answer. Okay.